Hey, welcome back to Polysthetic. In this video I'm going to talk about how I handled vibration on my mobile device in Godot with C#. Now, vibration is simple enough. So for example, let's say I have a class that derives from texture button, which is an inbuilt Godot class. All I have to do is call input.VibrationHandler, and here I pass in some duration, like 100 milliseconds, for example. And that's it. But now if you're building a project with any sort of complexity, you're going to encounter three problems. First is, what if the user wants to disable vibrations? The second is, how do we handle all of these durations? You want some way of standardizing them without using magic numbers everywhere. And the third is, this one's a little more subtle, how do we handle the differences between Android and iOS devices? The problem here is iOS only handles vibrations for half a second, so 500 milliseconds. So if you're building to Android, you can choose to vibrate the device for 50 milliseconds every time a button is pressed, and that actually feels good to the player. But if you vibrate every time a button is pressed on an iOS device, that gets annoying really quickly, because every button press will vibrate the device for half a second. Now, the worst way to handle all of these things is procedurally. By that, you can maybe just create some sort of global Boolean variable that determines if vibrations are enabled. Like some kind of game settings class. That could be static or a singleton. But then of course you'll have to nest this if statement and check to see if the device is an Android or an iOS device. And then of course with these durations, you'd probably want to create a bunch of fields like private constant integer, vibration duration. And here you're going to clutter your code a lot. Every time you want to vibrate the device, you're going to have a bunch of nested if statements, local fields, private fields everywhere, or a whole bunch of global constants, which you don't want. So you can see that the procedural approach, which is what we're seeing now, breaks down quite quickly. But here's a good opportunity to demonstrate some of the advantages of object-oriented solutions, in particular polymorphism, as we'll see here. Of course, you can solve this problem any number of ways. But the way I did this is using a static class called the VibrationHandler. So let's take a look at that class now. So it's a static class, and what it has is a static property called Vibrator. And the type of this is BaseVibrator. So let's go into that. And you'll see here that this has the makings of an abstract class because it's just a bunch of empty methods, but I did not mark it as abstract. And all of these virtual methods could also be marked as abstract, but I haven't, and I'll explain why in a second. But as you can see here, what we have is a bunch of empty methods. For example, on button press, on player hit, player destroy, etc., which list out the vibration events, basically. So any object in-game that would want to vibrate the handheld would first go to the vibration handler, which is a static class, find its vibrator property, and call one of the methods. And within these methods, this is where we call the input.vibrate method. Now what we do here, when we initialize this class, we enable vibration by default. But this method is called later when I load the game settings. I either enable or disable it. Now, first, if I want to disable vibration, so if enable is false, here we assign the vibrator a new base vibrator. But remember, the base vibrator doesn't do anything. So it's just calling a bunch of empty methods. And that's how we disable vibration. But if we want to enable vibration, here we're going to check what the vibration device is. Now, although this method signature says it's going to return the type of base vibrator, it actually checks to see the operating system name first. So if it's Android, it'll return a new Android vibrator. which inherits from BaseVibrator. And in this single class, what we have here is a bunch of constants which determine the vibration duration, and it overrides all of these vibration events. And what they do is it calls the input.vibrate_handheld method with these constants. And let's say the device is iOS. I'm not sure if this name is correct, but this is just for demonstration. We can return a new iOS vibrator. So we can generate this new class of the type BaseVibrator. And so here we just override the methods where we actually want to vibrate the device. Remember, on iOS, they're all half a second vibrations. So you can say public override void on player hit input vibrate handheld. And that's it. That's it for iOS vibrator. And all the other methods, just keep them empty. Or, we can override the events where we want there to be a vibration, and leave out the ones where we don't want there to be a vibration, like a button press. Yeah, so this is my implementation of vibration handling. As I said, it uses polymorphism here. It avoids a lot of if statements, and it allows for easy enabling, disabling, and it groups all your vibration durations in one location. Now, of course, there's a whole bunch of different ways you can do this. You can load some kind of global script, you can load a singleton, you can use signals, but I think this method is very robust and very simple to maintain. Okay, thank you for watching. If you have any feedback, please let me know in that little box down below, and I'll see you in the next video.